Hello class, it's Miss Aaron's here and Mrs. Covarrubias and Mr. Covarrubias.
Hi guys.
He's waiting for Miss Covarrubias. We're going to make this video really quick. We're going to talk about the rules for naming covalent molecules. So first off, we're going to start with the prefixes for the first item. Our example here, we have phosphorus, and since there's only one phosphorus, we don't need any prefix for it. So that's going to be our first item. So no prefix if there's only one of them. So you might want to write that little rule down.
Right, so you can see here that the second atom, if there's only one of them, we're going to label it with mono. But if we just write phosphorus here, everybody
knows that there's only one.
Just assumes if there's one. So we just would write phosphorus.
Okay. So then our second atom there is going to
be... there's never any ending change. The ending's always the same.
Okay. So then our second atom is going to be, we have 5 there, 5 chlorines. So then we are going to add the prefix for 5, which is going to be penta. Okay. And just naming it down here. So monos 1, dis 2, tris 3, tetras 4, pentas 5, hexas 6, hepta is 7, octas 8, nona is 9, and deca is 10. So we are going to add the prefix, so it's going to be penta, and then it's going to be chlor. And then we have to change the ending to IDE.
Just like an ionic bonding.
Yep. And
that's the only change.
That's it.
There's never any polyatomic ions that are 8 or 8. So
nothing like that. You just have to remember, I guess, really is the prefixes.
Yep,
and
so
then
you'll need to have these memorized because you won't have these on your test.
The ending, you just have to change it to IDE. It's pretty simple.
And the reason that we're having to write the number is because in covalent bonding, unlike ionic bonding we could use the charges to figure out how many there were supposed to be by doing the crisscross method. In covalent naming, we don't use charges. It could be an expanded octet, it could be a shrinked octet, it could be anything, and so the charges don't cross, and that doesn't work out in this case. So that's just a little note over there. So let's do another example, like maybe the C2H6. This one's on the worksheet that they were doing today, or on your worksheet.
So let's start with the prefix. So we know that there's 6 of them there, so we're going to have to use the prefix. Oh, sorry, first atom first, sorry. 2, so there's going to be 2 carbons. So we're going to use di, carbon, don't have to change the ending. And then there's 6 hydrogens, so we're going to use hexa, hydrate. Changing.
Instead of it's just always hydride.
Instead of the O hydrogen, yeah, you're going to change it to ide.
Okay, so we'll do one more example here. How about silicone,
or
I don't want that. That's not what I want. Oxide. Yes, that's what I want.
No, 4.
Sorry. Okay, so silicone, there's just one, so we're just going to write out silicone. And then there are 4 oxygens, so we're going to say tetra oxide. Okay, it's pretty simple. This chapter is not difficult because of its naming. It's difficult because of its drawing. So a little different than last chapter. So that's all there is on that. So you can practice on your review by naming all of the molecules that you are drawing.
Yep. You'll have a quiz on Monday. Open notes. Have a good weekend.
Yay!
It's pretty. Yeah. It's okay. It doesn't matter. Hey.